All right, hello everyone. I'm Joe Hemler, co-founder over at Gotham Digital Science. Also with me today is Marcin Yugaszewski, one of our top security engineers. Today we're talking about web hacking. So at the end of today's session today, hopefully you're going to walk out of here familiar with vulnerabilities commonly found in web applications. And our other main objective is to teach you guys how to identify and exploit web application vulnerabilities. So here's what we're going to cover today. Before we actually talk about some of the vulnerabilities that you commonly find, we're first going to do like a quick primer just to make sure you understand the basics of a web application. Then we're going to get into some specific vulnerabilities, and then at the end we'll just cover a basic web testing methodology that'll help you for the homework assignment. All right, so let's get into the primer. So pretty much most web applications, they're built using the HTTP protocol. HTTP is a stateless protocol that consists of a series of requests and responses. Essentially, a request is going to be comprised of a method, headers, and potentially a body. And then a response, or an HTTP response, the key pieces are, again, the headers. There's going to be a status code, and then there's going to be a response body as well. And then lastly, just keep in mind that HTTP is a plain text protocol, and so for the most part, it's going to be fairly easy to read and to manipulate. So some common HTTP request methods. So let's just look at this. This is a raw HTTP request here, and let's just look at some of the parts. So firstly, you see the word get. That's the type of method. And we're retrieving a resource called search.jsp. Then you'll see a question mark, and everything after that is called the query string. And essentially, those are just name-value pairs. Those are the actual request parameters. And then the HTTP protocol, that's a version of the protocol that's in use. And then we have some request headers here, like the user agent identifying the browser in this case, and then the host where you're actually requesting the resource from. Another common method that you're going to encounter is the post method. It's fairly similar to the get, except that the name value pairs now, or the request parameters, are actually being passed in the body of the request. HTTP status codes. These are, so basically the server, these are returned by the server based on the results of a particular request. So we have 5 different categories: informational, success, redirection, client error, and server error. So some of the more common status codes that you're going to encounter are these. So the 200 OK, so that means that the client made a request which was found on the server and it got returned back to the client. So that was a successful request. Another common status code is 302. So this is essentially a redirection. So this tells the browser that essentially the server is telling the browser, hey, the resource you requested, it's moved somewhere else. Go find it over here. 401 unauthorized. This is essentially where a client makes a request to a resource and doesn't have sufficient authentication credentials to access it. So it basically tells the client, you're not authorized for this, supply username and password. 403 forbidden. This is essentially where this is a request for a valid resource. However, you're not permitted to access it, even if you have valid credentials. Essentially, there's some other control in place that's preventing you from retrieving that resource. Whether it be like it could be, for example, like a file system permission that's preventing access. 404 not found. This is probably the one you're most familiar with. This means you requested a resource that just wasn't found on the server. And then lastly, the 500 internal server error. This means that the request that's sent in caused some kind of error on the server side. And from a testing perspective and a hacking perspective, these are all quite interesting, but the 500 internal server errors is going to be very interesting too. As we mentioned, the HTTP protocol, it's stateless. So in order for an application to be meaningful, usually there's going to be some type of state tracking mechanism. Typically, you'll have, this is in the form of like a session identifier, and that session ID is used to group a bunch of requests or uniquely identify a bunch of requests to a particular session. And that session ID, you might see it passed in different places. You might see it in the URL. You might see it as a hidden form field, which is really just a post parameter. or you might see it in a cookie, which is an HTTP header. So cookies, this is probably the most common place you're going to see a session identifier being passed between the client and server. What usually happens is the client makes there's a certain request that's going to initiate, it's going to result in the server setting or returning a set cookie header. And in that set cookie header is going to be the cookie name and then some attributes about the cookie. So we have an example here. This is just, it's a pretty simple session ID. And this basically instructs the browser to send this cookie for every request for this particular path domain. This cookie is valid for this amount of time. That's the expires attribute. And then some other attributes you might see in your testing is HTTP only, which basically prevents script code from reading the cookie. And then also another attribute to be aware of is the secure attribute, which instructs the browser to only send the cookie over an encrypted channel. So we've gone over some of the key aspects of the HTTP protocol, including requests, responses, and state tracking. So now we need a way to sort of hook into this protocol and basically debug the application behavior. And the way we do this is with an HTTP proxy. So traditionally, when you're debugging an application, you're going to attach to the process with a debugger, for example. But when you're doing web testing, usually you don't have the luxury of attaching to the server. So that's what we have our HTTP proxy for. And that essentially allows us to intercept all the communications between the client and the server. So both the requests and responses, and it gives us basically read and essentially write access to all the requests. So the particular proxy that you use during your testing is really up to you. It's a matter of personal preference. I'm going to show a quick example of one here. So firstly, here we just have a sample application that's called WebGoat. You might even already be familiar with it. It's basically a learning tool from the OWASP project. It's got a bunch of vulnerabilities baked in. So what we're going to do here is let's say WebGoat is an application we were going to be doing some testing of, and we wanted to sort of get under the covers and see what the communication looks like between the browser and the server. So the first thing you need to do is go to your browser settings, specifically network settings, and configure it to use a proxy. So I'm using Firefox here. You do the same with any of the other major browsers. So I'm going to set it here to connect to a proxy on localhost at port 8080. And the proxy I'm using for this example is called Burp. It's freely available. Download it at portsbigger.net. And just to sort of show you why I set it up the way I did in the browser, we have it configured here to run on, this proxy is running on port 8080 on localhost. So now what that's going to happen is the browser is going to send, when the browser makes a request, it's first going to get sent to this proxy. The proxy is going to intercept it, allow us to view it, edit it, and then it's going to forward it on to the server. Turn intercept on. You can't see right now as the proxy is blinking. Okay, there we go. So here's the request. So you can see here it's a GET request. Again, we're making a request to a resource called attack, and you can see the query string parameters. You can see some other interesting things. You can see the actual cookie being passed. There's a JSession ID there. All the different headers. There's an authorization header that we'll talk about a little bit later on. A little better?
Yeah, much better.
Okay. So there's the raw request. Again, the method, you can see the resource being requested, the parameters, etc. And then here's the actual raw response coming back as well. And if you wanted to, you can manipulate this. Let's just take a quick look at So, and it's just again example of a post request. There's all the parameters now in the post body. So you saw before in the get, you can normally with the get request you can usually like edit those, manipulate those parameters in the browser address bar. With post parameters, it's a little bit more difficult to actually edit those in the browser. There's ways of doing it, but the proxy makes it the easiest. And now we can essentially just change these to whatever we'd like. And we'll talk more about why we would like some techniques for manipulating these parameters a little bit later. But just wanted to give you a feel for, or it's sort of like the level of access that you have now to the communication between the browser and the server, and different ways you can manipulate the request. So now we've talked about a little bit about what makes up a web application. We've talked about one of the primary tools you're going to use to test a web application. If you've never tested a web application before for security vulnerabilities, where are you going to start? So a good place to start is the OWASP Top 10. By show of hands, how many people are familiar with this? Okay, good. So it's basically it's a listing of some of the more common vulnerabilities you're going to find in web applications, and essentially think of these as more of categories of flaws. So, for example, injection is pretty vague in what it could mean. So, some specific examples would be like SQL injection or LDAP injection. Again, broken authentication and session management is a very vague, kind of broad sweeping category. There's many specific issues that could fall underneath that category. So I just don't want you to think these are the only things that you're just testing for these 10 issues. There's a wide range of different issues you're going to be testing in web applications. So let's talk a little bit about some of the specific categories now. Injection flaws. So these flaws is essentially injection type flaws are the result of mixing code and data, and then passing that as a single command to an interpreter to be parsed and ultimately executed. So essentially, the interpreter is going to execute the command, and examples are going to be things like SQL injection, OS command injection, LDAP injection, and so for SQL injection, the interpreter would actually be like the database server, or for OS command injection, the interpreter would actually be the shell. So here's a fairly vanilla SQL injection example. So firstly, we have our code, which is the SQL query, which is then mixed in with some input, and we have a single SQL command. And so normally, if we just submit a username and password, so username jsmith, password of secret, that gets added into our SQL query, which gets passed to the server for execution. And what's going to happen is a record is going to be returned where user ID equals jsmith and password equals secret. That's sort of what we'd expect. So now, where you have the vulnerability is, again, you have the code, which is the SQL command, being mixed with the input, which is the user ID and password values. Can anybody think, again, given that sort of that combination, what's going to be the end result? What would an attacker try? Anyone? Want to throw it out there?
Escape it and delete the whole database?
Sure, you could do that if you wanted to. You could basically break out of the intended query and then add maybe a delete table or drop database kind of command. That would be extremely dangerous. I wouldn't recommend doing that necessarily. But maybe what you might want to try is, again, to your point, it's manipulating the intended query. And here in this example, we're just appending the command or 1 = 1, which is always a true statement. So essentially, when this query gets executed, we're going to log into the application without a password. So let's do a demo. So what I have here is Gotham Digital Bank. It's a completely fictitious website. And it's using a self-signed certificate. Actually, that's the proxy. That's because we still have the proxy configured, so we're accessing the site over HTTPS. All right, so here's the login. So when we're going about looking for SQL injection vulnerabilities, we're going to be looking at the different parameters that are being passed. We already talked about some of the different requests you might see a get versus a post. In this case, we have some values being passed in the query string. So these are easy targets. So let's try manipulating some of these. So one of the things we would try when looking for SQL injection is working through each parameter and trying different control characters. So we're going to try a single quote in this example. And when we do that, we get a nice detailed stack trace coming back to the browser. And there's a message there saying input string was not in a correct format. Interesting that we've been able to cause an exception, but not that interesting because this doesn't look like a SQL exception. This looks more like a format exception. So let's keep looking. Can you guys see the URL? Okay. Just do this. I'll try and do this for everyone. So that's what we put in. So the %27 is the URL encoded form of single quote. All right. Next. So the next parameter there is called account key. We're going to try and we're going to append a single quote there. And now we're getting a little bit more of an interesting error message. Here, this is actually a SQL exception, and it's saying unclosed quotation mark before the character string, and then you see the actual value that was passed in the URL, and you can even see part of the SQL statement. You can see it actually says like order by transaction date descending. So this looks like we have a possible SQL injection vulnerability. The next thing we're going to try is, so we caused an error, and if you look closely at the message, it is it's a syntax error. It's saying there's an unclosed quotation mark before the character string. So what we want to be able to do next is try and get a syntactically correct SQL statement so that we can actually run queries on the server. So one of the things we want to try is injecting in the double dash character, which is a SQL comment character. So basically, because it looks like we're actually injecting into a where clause, so there's some criteria. We're injecting our single quote into what looks to be a where clause. We're basically going to, we already have our single quote. We're going to put a dash in here that's going to basically comment out the trailing SQL. So we're just going to have a syntactically correct SQL query, and that's going to get run by the server.
I have a question.
Sure.
At this point, have you become illegal if you were doing this on a normal website?
I wouldn't say.
Well, consult your lawyer.
Yeah, I mean, not yet. I haven't actually retrieved any. I haven't retrieved any data yet. I haven't necessarily done anything malicious. I mean, it's kind of a gray area. All right, so now you've actually got now when I ran that particular query, what actually came back is actually valid data back to the browser. So we now know that we're going to be able to manipulate the SQL query and get the database server to execute what we'd like. So now that we've got we know what's required syntactically, we're going to start actually retrieving data from the database server. So I would say this is where it probably starts getting illegal. So one of the ways we do that is using the union query. So the idea is you want to union your query with the original query and get both results returned to the browser. All right, so what I'm going to try here is I'm going to say, let's append union select blah from blah, and then comment anything after that. And what happens now is we're getting a different error message that's basically saying invalid object name blah. So we're making progress here. So it's actually recognizing our union query as being valid. The problem is that there's no database object called blah. So one thing I haven't pointed out yet is you can typically identify the backend database server based on a number of factors. And in this case, we have error messages coming back. So the error messages, based on their contents, will typically reveal to you what kind of database server that you're dealing with. So in this case, just being familiar with the different types of error messages, I knew that this was a Microsoft SQL server. So I'm going to end up querying the master database for a table called sysdatabases, which contains a catalog of all the actual databases on that particular server. So if you're doing SQL injection testing and you encounter a particular error message that you're not sure about, you just basically take that, copy it into Google, and you'll pretty much be able to find quite a bit of documentation on the error message, and you'll pretty much be able to figure out what kind of database server that you're attacking. All right. So now it's saying invalid column name blah. So now we're just going to change that over, and we know a valid column name would be name. And so now we get a completely different message which says all queries and SQL statements containing a union operator must have an equal number of expressions in their target list. So in order to union your query with the original, you need to match up the same number of your union query has to have the same number of columns as the original query, and additionally you need to match up the data types. So basically what you would do is you would just start just incrementing number of columns by 1. I'll just keep on using the name column. And just to sort of cut to the chase. And so essentially there's five columns were needed to make the query successfully execute, and now I'm getting all of my transactions associated with my account, but I'm also getting a listing of all the databases in the back end. So now that I know the databases, I'm going to pick one and go after it, and then we're going to want the list of tables within a particular database. So that we know this is Gotham Digital Bank, so we're going to go after the GDB database. So I'm going to say select name from GDB ... sysobjects. I'm also going to say where x type equals u. So this is basically going to give me a listing of all the custom database objects within the GDB database. And so now when I run this query, now I'm getting a listing of all the tables within the GDB database. So there's definitely some interesting ones, like table user. There's one called table CC, TBLCC. So let's go ahead and go for that one. So the query we're going to use for that is so I'm querying another system, actually querying a system view here. And there's a number of different ways to get this information. I'm just taking one of the easiest.
Basically, all this query does is retrieve the column names for a particular database
Table.
table.
So now we've got a listing of all the columns within the TBL-CC table. So now essentially we have everything we need to actually query the TBL-CC table. So let's go ahead and do that. For now, I'm just using placeholders instead of column names, just to keep the output a little more formatted a little more nicely. Let's see. What's that? Dots. All right. So hopefully we got it working here. Okay, let's give this a go. And there we go. We got a listing of all the users, the credit card numbers, and the CBV2 number. So pretty much what you need to commit identity theft at this point.
Don't recommend you actually do that.
Yeah. So that's sort of a soup to nuts example of how you go about identifying SQL injection vulnerability. Some of the steps you would take to enumerate the schema and then ultimately pull the data out. Now, I went through it in painstaking detail and went fairly slow. A lot of those steps can be automated There's tools that automate it. But I would definitely say for the first couple of times that you're learning to test for this kind of vulnerability or even exploit it, you certainly follow the manual steps as opposed to just running a tool, because then you're not really learning how to actually do this on your own. All right, so what you would so we got access to credit card numbers, and we could sell these in the black market and make lots of money. You might want to take it still yet one step further. So what you may want to do is see whether you can actually compromise the database server itself, and usually that's sitting on an internal network somewhere, in a database server. In a data center. So if you compromise that back-end database server, you're sitting pretty on the internal network and can launch all types of internal attacks. So to compromise the database server, we're going to have to, we need to check whether we even have the ability. We need to check what privilege level the database login that's being used by the application, what kind of privileges it actually has on the database server. So we can actually test that through some SQL injection, or really through some different SQL queries. So we're going to try a few of those. All right, so I'm basically running a query here to check whether the database login is within the sysadmin server role on the SQL server, and if it is, we're gonna tell the database server the current database server thread to sleep for 15 seconds, and that'll be fairly if this is true, if this turns out to be a true statement, it'll be fairly noticeable. So now I've run that. If you actually look in the lower left-hand corner, it's saying waiting for Gotham Digital Bank. So essentially, because the database server is now hanging for 15 seconds, the current request, the thread here for the HTTP request is hanging for 15 seconds, and then we did get this error coming back, but it looks pretty promising that we're actually accessing the database in the context of a privileged database login.
Question?
Yep.
What was the purpose of the delay again?
So the delay, because basically we're running we're performing a conditional statement here. We're basically saying if, let me put it back over here. We're saying if the current user is in the role sysadmin, if that's true.
You mean for like debugging purposes, just so like you have some sort of, it's like an alert.
Yes.
Okay.
Yeah.
But there's nothing special about the delay. We could have done anything else, right?
Well, potentially, but the delay makes it easier. It's a sort of it allows you to basically test whether you've actually executed the command or not. Otherwise, you may not have any way of determining whether that was successful or not.
So it's the easiest way to determine if you're.
It's one of
the ways, and this way is specific to Microsoft SQL Server. The use of wait for delay, and even like the check for is server role member. Again, that goes back to what I was talking about earlier, knowing what the backend database server platform is. So each of the different database servers have different ways of doing this. So you just have to know. There's plenty of documentation out there on the internet telling you the different types of functions to use to determine make similar kind of checks.
And in upcoming slides, we'll go over some other techniques you can use to determine whether a SQL query has actually run successfully or not. This is just one of those techniques that you can use.
So now that we know that we have a privileged database login, and basically is a member of the sysadmin server role, we can actually execute privileged functions on the SQL server, and one of those happens to be XP CMD shell. So that's an extended store procedure that actually lets you execute operating system level commands. So what we're going to try and do now is upload netcat onto the database server, and then essentially have it shoot it. We're going to set up a netcat listener on our end, have it shoot a shell over to us, and we'll end up getting console on the backend database server. So in order to, we need to get netcat up onto the server, so I'm going to set up a sort of a TFTP server on the attacker's machine.
Not missing anything here. We're just setting up TFTP locally.
Yep, so I'm just setting that up, starting it up. And what I'm going to try now is this particular command, so execute master.xp cmd shell, execute the TFTP command, connect back to 192.168.138.1, which happens to be the attacker's IP address, retrieve the netcat executable, and then copy it over onto the server under a directory called temp, copied as nc.exe. All right, so that ran. You can see the connection was made. So you can see the connection was made from the database server. Netcat was retrieved. So now it's there. Now we're going to basically send a shell from the database server to our listener. So let me set up a listener.
Is TFTP come packaged with servers generally?
It is on Windows Server 2003. Yeah, and that's just one. That's just how I'm going the easiest path right now.
Right.
Yeah.
There's other ways of getting executables on the server.
That don't involve third-party components.
Exactly.
Yeah.
This is just one of the easiest ones.
Yeah, it's easiest to demo,
For
basically.
the demonstration purposes.
So I've just set up the netcat listener on my machine.
I might be actually really interested in looking for that as well.
So now what I'm going to say is I'm going to execute XP-CMD shell, invoking the netcat binary I just copied up onto the server. I'm saying execute cmd.exe, which is a shell, and send it over back to the attacker at 192.168.138.1 listening on port 444. And with any luck, keep our fingers crossed, and here we have the shell on the server. So that's the actual backend database server. So we've completely got complete control of the backend database server. And you can also see the database server is running as a system, which is the most privileged account on the operating system. So we completely own that server, and from here we can launch all types of attacks against the internal network and basically own the all the data on that database server as well. Any questions about that?
Can we see the payload again real quick? I want you to call that payload.
You can call it a payload.
Yeah.
Oh, okay. Thank you.
Any other questions? Y'all think you can do that from the homework?
How many bags are still this week?
Excuse me?
How many bags are still this week?
Too many to name, no.
The thing about XP-CMD shell is Microsoft has actually disabled the XP-CMD shell functionality in SQL Server 2005 and later. However, it's still possible to re-enable it if the database server is running as sysadmin.
Which it was in this case. That's what allowed us to do what we did.
So if you ever find yourself exploiting a SQL injection vulnerability and the database user is SA or sysadmin, you can actually re-enable XP-CMD shell from SQL injection vulnerability, and then do the same stuff. Just some extra queries you have to run.
Okay, so that was the SQL injection demo, and just wanted to summarize the steps that we took to exploit it. And again, I think if you follow these steps, it'll be very useful on your homework. So once you found the SQL injection vulnerability, you want to fingerprint the database server, and you can do that by, especially if there's error messages being returned, that error message is going to usually provide enough information to help you figure out what you're dealing with in the back end. The next step is getting an actual working exploit. So the first thing I tried was sticking in the single quote, and then I talked about ensuring you have a syntactically correct query as well. So basically, that's why I was using the double dash, which is a SQL comment character, which depending on where I was injecting into, it was commenting out any trailing SQL and allowing for a valid SQL query. Then there's just some other variations you might have to try. So you're not always going to be so lucky to just inject straight into a where clause. There might be maybe you're injecting into a column name. You might be injecting into a subquery. So there might be other characters you have to deal with. So if you're injecting into if there was a query that was being within parentheses like a subquery, then you might actually have to basically inject a single quote, close out the parentheses of the subquery, and then comment everything out after. So there's a number of different sort of payloads you might have to try before you actually get a valid working exploit string. And then once you've done that, once you're able to successfully execute a query, you're then going to want to extract all the data from the database server, and you're going to do this through the use of a union statement. And then you're going to enumerate database schema. So we went after, once we were able to run union queries, we got the listing of databases, the tables within each database, and the column names within each of the tables. And then we dumped the application data, and then you're also going to want to make a check, do some checks to see whether the database login is privileged, and if it is, you might go after the operating system itself. Just a couple other notes. We talked about during the demo that when you're using the union statement, you have to match up the number of columns and data types. So what might be useful to you is actually instead of putting a column name in when you're testing this, is actually just using null. usually null will help you get around some of your data type conversion errors you might run into. And then also, the use of the group by clause might also help you determine the number of columns in the original query. So error messages, again, what are these useful for? They help us detect SQL injection, as you saw during the demo. They provide a feedback loop as to why your previous query wasn't successful. And then thirdly, they help you fingerprint the backend database server. So that's useful because you want to know what features are available to you, and then so you can basically pick and choose which attacks, which payloads you're going to end up using. So another technique that you have available to you is blind injection. So this is useful when the application has suppressed error messages, or maybe all you're getting back, the only data that you're getting back is either like a valid result set or no result set. So there's no error, but you're getting slight differences in the actual content that's coming back. So there's two different common techniques you're going to use to infer whether you actually have a valid SQL injection point. There's timing-based techniques and there's response-based techniques. The timing-based technique is what we used during the demo. And basically, this is a similar type of query where we're basically checking whether the system user is equal to SA. If it is, then we say database server, please sleep for 15 seconds. And again, it's just a way to, it's just a conditional statement, and then using this as your sort of the attribute that you're going to determine whether you've been successful or not. There's other commands depending on the database server. So there's the sleep command, for example. And then response-based techniques. This is just inferring whether your query was successful or not based on what comes back in the browser. So maybe there's no error message, but a successful query returns 10 results, whereas an unsuccessful query returns no results. So it's just like a simple example. Here we have a SQL query, and we're going to use the response-based technique. So let's just assume for this example that a successful query returns 10 results, an unsuccessful query doesn't return any results, and the goal is to basically enumerate or determine the name of the database login being used to access the database server. So again, the key, we want to make sure that we can successfully manipulate the query. So now, what we're doing here is we're injecting in and 1 equals 1. So 1 equals 1 is always a true statement. So in this case, when this query runs, all 10 results or 10 records should be returned. Now we append and 1 equals 2. So 1 is never going to equal 2. So that's never a true statement. And we've used the and operator. So this is always going to be false. So no records are going to return. Now let's just see. Maybe let's take a shot at maybe just guessing the name of the database login, and we try and we append the system. We run the system user function and say, is the username equal to SA? So it's not. So that's false. So now what we're going to do is we're going to basically enumerate the database login 1 character at a time using the substring function. So we're basically checking the first character of the call to system user, and if the first letter is actually an A, then 10 records will come back to the browser. But in this case, no records come back, so we know it's not A. So let's try B. We try B, still no records coming back. Now we try C, and we actually get 10 records coming back. So we know the first letter of the database login is actually a C. And you can kind of probably see where we're going with this. So then we move on to the second character. And again, we start all over again. We try A. That's not true. Then we try B, and now we get our 10 results back, and so now we know that the first 2 letters is CB. Start again on the third character, and so on and so forth, until you've run through, essentially, until you've gotten to the end of system user until you've worked all the characters, and then you've effectively just enumerated the name of the database login. So you can use this technique to actually pull data out of the database. I just used a simple example here of actually just enumerating the name of the database login.
There's also more efficient ways of extracting or figuring out this information. But this is just an example. That might be something you might want to research, is how you can actually reduce the amount of requests instead of looking through the entire alphabet. See if there's a quicker, more efficient way to identify what the username is.
Or even just enumerating data in general. Another blind injection technique is use of an alternative channel. So the idea here is retrieving results outside of the HTTP response. So in this first example, the attacker actually controls the DNS server for attacker.com, and so when the result of select user from Dual is actually going to be appended to .attacker.com, and there's actually going to be get host address is going to run a DNS query, and it's going to query the root DNS server for attacker.com, and if we own that DNS server, we can sniff the DNS queries and actually start getting the query results. So this is kind of a neat way to get data from the database server if you're not getting anything at all back in the browser. Another technique is attempting to use functionality such as ad hoc queries. So Microsoft SQL Server has a way to connect to other database servers and basically dump the results within a table. So here what we're doing is we're connecting to a database server 10.0.0.2, and we are dumping the results of this particular query into the table results table on that database server at 10.0.0.2, which is owned by the attacker. So essentially, we're running our query on the compromised database server. Those results are then being inserted into a table on another database server that we control. So it's sort of like a connect. You can almost get that database server to connect back to the attacker's database. So then again, there's a number of different ways of doing this. These are just two examples, and I think the point is if you find a SQL injection vulnerability and you're looking for ways to get data back in the traditional way of getting it back in the browser, or even some of the response-based techniques I talked about earlier aren't working for you, you're not out of luck. You can try alternative channels. This is just moving on from SQL injection. This is just another type of an injection flaw. This is just OS command injection. And this, again, it's very similar to the SQL injection example where you have code and input being built into a single command, which is then being passed to the Java runtime.exec method, which essentially just passes that on to the operating system for execution. So the attacker can influence the client ID value and maybe inject in some shell meta characters. And basically here we're using, it's a Windows system, we're using the double ampersand, or we're appending our own command here, which is net user. We're adding a user called hack with a password hack. So we just added a user account to the machine running this code. All right, so we've talked about some of the root causes of injection flaws. We walked through in detail exploiting it. So how do we go about identifying some of these injection flaws? So the first step is you need to identify all your entry points. Then, depending on the type of injection flaw you're going after, you're going to inject different types of payloads. And then the most important part is then analyzing the response and looking for anomalies, which will then tell you whether your injection attack has been successful or not. So can anybody, based on some of the earlier things we discussed, especially during the web application primer, can anybody think about different attributes about the response that we might be interested in when doing this kind of injection flaw testing? Yes?
One of our devs forgot to turn off like debug in our framework or something like that, and then we're giving anybody that makes a mistake a whole traceback.
Exactly. So that's definitely one thing we're looking for. So looking for any kind of like exception message coming back to the client. Anything else? Maybe there's some variable names coming back as well. That would be useful to us. What else?
Said absolutely nothing as opposed to a page that's supposed to be there.
Yeah, exactly. So that's differences in responses. Yep.
The 500 message.
Yeah, and then that's the other one I was looking for as well. Is that we talked about the different status codes. So it's important to know those are different status codes that come back in the response. So the one of the more interesting ones is the 500 server error message. So you would want to keep your eye out for that. So that's sort of the basic methodology, and then once you've gotten comfortable with that, then you're if you manually test everything, it might take forever. So you do want to leverage some level of automation. So if you're gonna leverage your injection flaw testing, then just be very careful before you do it. Think about what could be think about the back end and what kind of damage you could do. So it would not be a good thing if you're doing web testing professionally, and during the audit, because you're doing all this injection flaw testing, you end up knocking over the back end database server. So you just want to be careful about you just want to be careful about when to automate and when not to automate. Different types of payloads that you might try. Again, this is very simple example. Certainly not complete. But if you're looking for SQL injection, trying things like single quotes and the double dash. For always command injection, looking for meta characters to append other operating system commands. We haven't talked about cross-site scripting yet, but you might want to try putting in angle brackets. If you're looking for buffer overflows, passing in overly long strings. And if you want a fairly comprehensive list, maybe take a look at FuzzDB. That has all different types of payloads that you might want to try when doing your injection testing. And I keep calling it injection testing, but really probably a better name to call it is this is actually just really doing fuzzing. It's called fuzz testing. And when you're fuzzing a web application and you're focusing on the application layer, you're going to want to focus in on the most relevant parts of the request. So we talked a lot about the HTTP protocol. You probably don't necessarily, if you're going after application level vulnerabilities, you probably don't necessarily want to fuzz the entire HTTP request, unless maybe you're looking for vulnerabilities in the web server. But if you're just trying to focus in on the app, fuzzing things like the query string, post data, cookies, and then there are some other headers that you're gonna want to fuzz as well. And then as you kind of get more experience with your web testing, you're going to run into other technologies that maybe even run on top of HTTP. So just you need understanding that what those protocols are and sort of what parts of that protocol you would want to fuzz. So here's sort of an example of what I mean. So here's a raw request, very similar to what I think we saw earlier. So this is a post request to the WebGoat application. All right, so before ran out of disk space, what we were talking about was fuzzing the relevant parts of the HTTP request, focusing on the application layer, the actual application itself. So this is WebGoat again, and so maybe you'd start by fuzzing the ones I've highlighted here in red, but as you got to use WebGoat and got more familiar with the application, you would realize that you don't want to fuzz the JSession ID because that's actually needed to maintain the session. So if you start fuzzing that, then you're not going to get any meaningful results. And you might also realize as well that the screen and menu parameters essentially control which lesson that you're accessing. So again, you probably wouldn't necessarily want to, maybe initially you fuzz those and see what happens, but you might realize after a while that messing with those doesn't really get you very far. So then you sort of hone in on the parameters that you're most interested in, which would be the ones we've highlighted here in red. And you would figure that as you're testing the app, over time. So I know this isn't a tech-focused course, but can't move on without at least addressing some of the fixes for injection flaws. So basically, if you find yourself in the real world doing this, being a professional web application tester, recommending things like use of safe command APIs, so like parameterized queries, which are going to basically escape all the, we're going to escape the dangerous inputs, the dangerous characters. Basically allows allows the application to build a safe command, consistent server-side input validation, and using strong data types instead of strings where possible. And you're going to run into terms like whitelist versus blacklist validation. So whitelist validation is where you're checking for known good values and rejecting everything else. And two different techniques are exact match. So we have a very defined list of what should be allowed and rejecting everything else. And you have pattern matching where you're matching the input against a regular expression. And then you have blacklisting, which is much less effective than whitelisting. And this is where you're looking for known bad characters. And if you detect those known bad characters, then you reject the request. But this is really not the best approach to input validation. And from a testing perspective, if you see some type of blacklist filter implemented, chances are you're going to probably be able to find a way around it. And here's just an example of why blacklist filters can be ineffective. So you have a a vanilla exploit payload here of executing XBCMD shell. And what we have are just a couple of different ways you could actually represent that command. So if you were trying to build a blacklist filter, you know, looking for malicious characters or malicious strings, you can see here a bunch of different examples and different ways that command can be constructed, and it will be a very difficult task. And from an attacker's perspective, if you ran into the fact that there was some blacklisting going on, you know, using some of these different payloads would actually probably be really useful to you. All right, so that sort of covers injection flaws. We're going to move on to cross-site scripting next. Any questions about injection? Yes?
What was the website you recommended for different fields to show?
Oh, sorry. Yep, that was it's called FuzzDB, and that's the link right there.
Yeah, just do a Google search.
Yeah, if you just Google FuzzDB, it'll come right up.
Thank you.
All right, so cross-site scripting. This is when an application accepts input and then renders that input back into the response without doing any prior server-side input validation or encoding. Basically, this allows an attacker to inject script code into the application, and then that script code will be rendered into a user's browser, and it'll execute within the domain of the vulnerable website. And the result is an attacker can steal session cookies within that domain, access any data within the DOM, deface website content, maybe redirect to a malicious third-party website, or even use the cross-site scripting vulnerability as a launching point for installing, you know, backdoors or other malicious executables. So there's generally three types of cross-site scripting. Reflected, so that's just where, or it's called reflected or transient, and that's where the input is literally just echoed right back in the response. Then you have persistent, where you get the payload actually stored within the application, and then it's subsequently rendered on another page, which executes when viewed. And then there's DOM-based, which is due to insecure client-side JavaScript. So again, you just have some JavaScript code that's running in the browser that's getting user controllable input and then passing it to an insecure function like the eval, or maybe it's passing it writing it directly into the DOM, but a document.write. So here's a diagram. So this is just depicting what a persistent cross-site scripting vulnerability looks like. So first, so you have the attacker on the left, Alice on the right, and the application there at the bottom. So the attacker has identified a vulnerable page and is passing in some script code. That infects the application, which stores it. Alice then, you know, comes along later on, requests a vulnerable page, and when she makes that request, what's returned is the attacker's payload in the response body, and then she's effectively infected, and the code executes and does any number of the things I just mentioned earlier, stealing her session cookie, installing some kind of backdoor or something. Reflected. Oops. There we go. So I guess the first thing with reflect is you actually have to, because the input's being echoed directly back in the page, you have to find a way to actually get the user to get that code to execute against another user. So one way you could possibly do that is by sending them an email, and then that email would be a link to the vulnerable website with the payload embedded, and the unsuspecting user clicks on that, which then results in a request being issued from her browser back to the vulnerable site with the payload embedded. The site is infected. The response comes back, and now, again, the code executes against her. So we've got a couple cross-site scripting demos to show you. What we're going to demonstrate is we're going to use something called XSS shell and XSS tunnel. These are really cross-site scripting exploit tools. So what XSS shell is basically it allows an attacker to backdoor a user's browser and essentially establishes like a command control channel between the attacker and the victim. And once that channel has been established, you can then leverage that channel to access the vulnerable website in the context of a compromised user. And at that point, you're essentially impersonating the victim. And if that victim is like a privileged user of the application, you might be able to access privileged functionality. Essentially, you're bypassing authentication because you're accessing the application as the infected user. So, before I actually do the live demo, just again to sort of help you visually see what I'm talking about. So here you have an attacker. Here's the attacker. There's the website that's vulnerable. He's going to deposit his XSS shell payload into the vulnerable page. He's going to leverage the support form for that because that stores information persistently and it's viewable by all users of the application. Then you have the victim come along, and they view the infected page. Their browser gets backdoored essentially with the XSS shell payload, and now there's that channel between the victim and the attacker. And now the attacker essentially can tunnel requests through the victim and access all parts of the application, whereas maybe before they didn't have access to the admin functions, now they can actually gain access to the admin functions because essentially they're leveraging this user's browser session. So we're going to do a recording on this. I'm not braving this live. So, all right. So what we got here is this is the victim. This is the admin user called Joe Admin. He's logging into GDS Bank, not to be confused with Gotham Digital Bank. You can see he's actually, like I said, he's an admin user. There's a support forum here. And he's gonna I was just demonstrating what that looks like. Now here's the attacker system. The attacker, this is XSS shell, this is the console. I guess you can see, I'm just going to show you, there's some different functions on the left-hand side, but anyway, so now the attacker's logging in. He also has he has an account with GDS Bank. He's going to go over to the support forum, I'll post a message. I'll put a message in there and then put in some script code. Essentially, this is going to, when this executes, this is going to inject the XSS shell payload. So message is sent to the administrator. Now we're going to log out. I'm going to log in now as the admin again. Go over to the posted messages, and I don't know if you saw the screen flash right there, but the payload, basically the XSS shell payload just executed to the untrained eye. The unknown user probably didn't even see that the screen flashed, and so now essentially what happened is XSS shell is the page here is actually being framed. So if we go back to attacker console, there's the victim, that's his IP address. So now we can start messing with him. So we can send him a message that just says hi from XSS shell. And that's actually IE popping up. So yeah, so basically now the unknowing users can see this would pop up in their face. Really, if you're trying to be stealth about this, you probably wouldn't send an alert message. What we have been talking about is what causes cross-site scripting, different ways to exploit it. So now, how do you go about identifying it? So for reflected, it's fairly straightforward. You just need a certain payloads that you want to test with. Essentially, do some fuzzing and observe the response contents. And here, what you're actually looking at is when you're looking at the response, you're most likely less interested in the status code and more interested in what's actually in the response body, because you're injecting in, maybe script tags or other unique strings, and you want to make sure that those are being echoed back into you want to see if those are coming back into the browser as the actual script tag, and that it's not being stripped out or maybe HTML encoded. Persistent. How do you go about testing for persistent cross-site scripting? There's a lot of different ways to do this. One way you could try is, because what the nature of persistent is, the data enters maybe on one page and it gets rendered out on another page. So if you're injecting in a very unique string, you could then go through all your responses and essentially grep and look for that unique string that got injected in on the page where the data entered the application. And then for DOM-based, to identify these are a little trickier. Scanners are not very good at identifying these, so this is more of a manual effort. And you would, because this actually happens in client-side JavaScript code, you might actually just analyze the JavaScript and looking for functions that are used to retrieve user input, such as document.url, and looking for functions that output it, such as document.write, and then sort of trace the input to the output. We talked about blacklist filters. Again, when you're testing for cross-site scripting, you're most likely going to run into these, or into blacklist filters. So quite often you encounter an application that's maybe looking for script tags. So you want to be able to mutate your attacks and try other payloads. So there's a lot of different things you can try. Here we're just showing using an image tag and then calling JavaScript from the source attribute. Using different encodings. So you maybe want to URL encode your payload, or maybe you do a UTF-7 encoded payload, which is this one down here. So the idea here is that if the application's server side was looking for angle brackets, this payload would actually bypass that kind of blacklist validation. And then if you could get the browser to interpret this is a UTF-7 encoded string. If you can get the browser to interpret it as UTF-7, that'll actually execute in the browser. This is an older example of something. This was actually this could actually be exploited in Google. So here's some code. We're doing an HTML encode on the query string. Does anybody think this? Does anybody think this piece of code is secure, or is there maybe still a vulnerability here? Let's take a stab at it. So is that what you're pointing out as vulnerable? So that looks fairly safe to me. It doesn't look like there's any real user controllable input. Status check be exploited.
I mean, if show status equals false.
what do you have?
Is there a way you can inject something that says it's true or something?
Maybe, I don't know what that would get you. If your goal here is to execute arbitrary, to get JavaScript to execute against a user, I don't know if that would get you there. Any other ideas?
Status is one of your query string parameters.
It is.
It's a good observation.
Yeah. This is fairly classic. So what happened here is there's data being taken from the query string. The value is show status. And it's actually, you can actually see here, the value is actually being written into the response. That's what this essentially means. This angle bracket percent equals is writing into the response. And that's being wrapped with a call to HTML encode. HTML encode is going to be sufficient for, it's going to, if you had angle brackets in your query string, if you're in your show status variable here, in HTML code would actually convert it to the HTML entity equivalent, and so it wouldn't be treated as an actual meta character. But the difference here is that the input's actually being outputted into an existing script block. So all you really have to do here is just inject in a single quote, and then basically put in your JavaScript payload, and that'll execute. So you don't need to inject any script tags or anything like that because you're already injecting within an existing script block.
And most HTML encoding functions don't actually take into account a single quote character when encoding it. Most of the times it'll just encode a double quote, but not a single quote.
So again, just some defenses. So quite often, basically usually the recommendation for cross-site scripting is to encode the data before it's rendered. And so if the data is being written into an HTML context, then doing an HTML code is usually going to be sufficient. But if it's being written into another part of the response, maybe it's being outputted into a JavaScript block like we saw earlier, you're going to want to do alternate encoding. And if you check out this link here, it's from our blog. We talk a lot about performing encoding for the proper context. And then, in addition to encoding, and then also doing some level of server-side input validation. So that's cross-site scripting. Any questions?
I have a question.
Yeah.
So that last slide was has to do with how you could defend a server running an application from getting cross-site scripting. So what if the site's already it's just bad, and the user does go to that site? Is there anything that the user can do on their client machine to prevent something from happening? Like
Sure. So
antivirus or something like that.
yeah, I mean maybe antivirus. There's also like anti-XSS sort of filters and plugins for a lot of the popular browsers. But you don't necessarily want to rely on that as your defense to prevent against cross-site scripting. I think it's maybe a good initial defense, but not everybody's going to have those installed.
Right.
So maybe you personally maybe have that installed, and it would.
Well, that's the thing. An average user wouldn't
Right.
know to defend against this.
Right.
And they could be surfing whatever out there.
Right.
The hard part, there's no way for a browser to tell the difference between what's valid JavaScript and what's invalid JavaScript, other than some browsers have built-in anti-XSS protections through the URL. So if you have a reflected XSS attack, most common browsers these days, like Google Chrome and IE8 or IE7, 8, and 9, have a XSS filter that look for common XSS looking payloads within the URL. But when it comes to like a stored cross-site scripting that's already injected on the server, I mean that's served up to a user, there's really no way for a person to be able to detect that.
Even the ones that do track data flow from the URL bar into the application, into the DOM, people make a sport out of breaking these.
Yeah. So it's not something you can really rely on.
Yeah. They're all like kind of indicative of more like a blacklist approach or whatever. They're going to fail even for the people that are like street conscious and trying to protect themselves with that. That doesn't mean that access isn't possible even to the things it claims to be protecting against. And like what Marston said, it only is able to protect against a very limited set of access flaws that are possible.
Another thing to remember, the browser is a very hostile environment for code to run in, and code can be introduced through any number of means. So we won't get into all of them today or next week, but that might be something you might take up as a research project and find different ways of having script execute in a user's browser.
This makes me want to just use my computer and not get on the web anymore.
Right.
I don't want to get on the web anymore because of that, but all right.
It's only XSS.
Okay. All right.
Any other questions on cross-site scripting? Okay. I'm going to now talk about insecure file handling vulnerabilities. So in general, this class of, or this sort of category of issues where you have unvalidated input combined with the use of some type of a file system API. So one of the more common ones, and maybe one of the ones you may be more familiar with, is file inclusion bugs. So this is where you have an include directive. So the code has an include directive, and that include directive is used to include code from another file. So you see this a lot in PHP, where, or even maybe something like classic ASP, where the developer wants to compartmentalize all their code into a single file and then reference it from other files, and so they use the include directive to do that. But sometimes what you'll see is that they want that page to be included to change at runtime, so it's dynamic. So they'll actually pass the file to be included as a request parameter. And so if that's being passed as a request parameter and the attacker can control it, then the attacker can control what file actually gets included. And so essentially that can result in either remote file inclusion or local file inclusion. So remote file inclusion would be where you pull a script off of a remote server and get it to execute on the actual web server that you're attacking. So that's really nasty if you can manage to do that, basically loading remote code onto the server and then getting it to execute. That's pretty much more common for PHP applications. You don't really see that in other places. In the sort of modern versions of PHP essentially have this kind of remote file include functionality turned off by default, so that somebody would have to go out of their way to turn it on. But still, there's the local file inclusion, the possibility to include local files. So maybe if you could upload a file onto the server by some other means, or maybe there's another file on the file system that you're interested in reading, and then you could basically view that by passing it to the include directive.
Another way to exploit this is application server logs. If you actually insert PHP code and say like the query string of URL, and then try and actually include the log file, the request log that that URL was written to, you may be able to get code to execute through that file inclusion as well.
And there's just an example there where this is a remote file include where you're actually pulling in rooted.php off the attacker server, and it's going to actually run on target.com. That's pretty much as bad as it gets. Okay, so this is anyone see another kind of insecure file handling bug within this code? Yep. Yeah, so essentially the file name, so the code is reading a file off the file system, returning the contents back to the browser. So you control the file name parameter. So you can pass in something like etc password, and it'll actually get read and then returned back to the browser. So this is commonly one of the common names for this is arbitrary file download. So here's a variation of that code. So now the developer's taking a step further and actually requiring that the file extension be it's appending the .jpg file extension, making it a little bit more difficult to actually retrieve any file on the web server. But does anybody think of something you might try here to bypass this?
Poison null byte?
Yeah, so using a poison null byte. So the java.io.file class, basically, if you pass in a null byte, anything after that, it'll ignore. So if you passed in like Etsy password, Etsy/password, and then null byte, then the .jpg would be dropped, and still would get the password file would come back to the client.
So this is a Java example. This also applies to PHP. Basically, any language that is basically based on C and does file handling in C is usually vulnerable to a null byte type injection.
Another type of issue to look for is insecure file uploads. So what this is where there's functionality to actually upload files onto the web server. So maybe a common example is you have a profile, a user profile in the application, and you're able to upload like an icon of yourself, some kind of picture of yourself. So maybe there's some validation that's being done on the upload that's looking for that checks the file type or checks the content type of the file, or maybe even does some validation of the actual content. So what you would try and do is basically, instead of actually uploading an image file, for example, you would try and upload an arbitrary file, something like so if the application is a PHP application or if it's a Java application, maybe you want to upload a file that would actually get executed by the web server. So you don't want to upload your own JSP file or your own PHP file. So something like there's a lot of different shell, like web shells they call them. So there's a JSP web shell, an ASPX web shell. Essentially, what that does is it gives you an interactive command shell on the web server. So you would want to upload that kind of file onto the server. And if you could actually get it uploaded and get the server to execute it, then it's pretty much game over. You're executing commands on the web server. If you can't, maybe what you resort to uploading some kind of a malicious executable and getting a user to download that, and then you exploit their local machine. So we're going to try one more demo just to show you an example of this, of how you might go attempting to upload arbitrary files onto a web server that allows a file upload. So we have another sample application here called Damn Vulnerable Web Application. And my virtual machine's running really slow, but this is another learning tool like WebGoat. So this is something you may want to download and play around with to understand how to identify and exploit web application vulnerabilities. Here's a file upload page, and it's basically asking us to upload an image file. And so all right, yeah, okay. So file got uploaded, and it's actually telling us where it uploaded the file to. So what you would want to do next is then see if you could access that path. See if you could access the file that was actually uploaded. So is that file being uploaded into a web accessible directory? All right, so it looks like the image was successfully uploaded and it's being placed into a directory that we can actually access. So can anybody think of what we might want to do next? So we know we can upload files. We can access the directory where they're being uploaded to. What is something we might want to try?
Upload a shell.
Yeah, so we want to try. Let's try and upload a shell. So I happen to have something called PHP shell.
Shell with source code as
Sure.
So this is very basic PHP shell. If you can,
No friends.
yeah, so basically it's just taking the command from the request and it's going to pass it to shell exec and just output the contents to the response. All right, so that was the shell we just tried to upload it, but the application is saying this image or your image was not uploaded, so not successful. Okay. So of course we want to try and figure out how we can do this. We're going to use our burp proxy tool to help us. So we go and look at the history. And we look at the upload request. So this is the one that we uploaded. This was the upload for the image. So there's a bunch of binary data. So some things you might want to try at this point is, playing around with the file extension, and then also maybe playing around with that content type header. And then here is our PHP shell that we tried to upload, which failed. And you can notice the content type here is application/octet stream, and the content type here is image JPEG. So maybe what we try is we try taking this image JPEG content type, and because this is coming from the client, we control this information. Replace the application octet stream with image/JPEG. So I'm so used to all right. So here is the wrong request. Let me go back. I want to send this one. So what I'm doing is I'm taking this request and I'm sending it over to Repeater, which is just another utility built into the burp suite. And what Repeater does is it allows me to manually issue requests outside the browser. So it's a really handy utility. So this is the raw request. And there's the content type. So let's just maybe see what happens if we change this. Put image JPEG. I'm going to issue the request. And response came back. And trying to render it, that was probably not a good idea. And you can actually see that it looks like the file was successfully uploaded. And again, we know exactly where it's being placed. Let's just put that in there. Let's copy that. Back over here. All right, so this looks pretty promising. So now let's just do something like CMD. I typed cat Etsy password. and there's the contents of the password file. So at this point, you could basically execute any command you want on the server. So that was just, basically to summarize, the developer was trying to enforce upload of image files by checking that content type request header, which is completely controllable by the user. So we basically spoofed that and changed it to image JPEG. So that's one of the techniques you would want to try if you encounter this kind of a situation. All right, so let me wrap up. So identifying these kinds of bugs. Essentially, the best advice I could give you is when you're crawling through the application using that burp proxy burp proxy tool, or even just paying close attention to maybe the URL address bars, it's just looking for parameter name value pairs that look like there might actually be passing files. So if you see something like file equals, that's probably something you'd be interested in. Or if you actually saw a file path being passed in the query string, or maybe in a post parameter, you'd want to take a close look at those. And then once you actually identify a page that you're going to try and, whether try and exploit file inclusion or if it's an arbitrary file download, is, as you're trying different, as you're attempting to load different files, just looking for messages like file not found or path not found. Those are the types of things you'd be looking for in the response. And just jump down to just the basic web testing methodology, so you hopefully prepare you for your homework. So basically, when you're testing a web application, sort of the main things you're going to be doing is you're going to be fuzz testing, so looking for injection flaws or things like cross-site scripting. You're going to be testing the security of the authentication mechanism. Didn't really talk about that today. We'll talk about that next week. Same with authorization testing. But basically, you're going to be performing tests and asking the question: can the authentication be bypassed? Can authorization be bypassed? And then lastly, information disclosure. So looking around for any places where the application is disclosing exception messages to the browser or other detailed error messages. So some tools you're going to want to use. You're going to want a web browser, something like a Firefox is probably a good place to start. You're going to need your HTTP proxy. I happen to be using Burp. Another common one is Fiddler. Ideally, you'd like to have some kind of a scanning engine to assist you with doing some of the automated injection attacks. You're also going to want a utility that's going to allow you to manually craft requests. So you saw that I used Burp Repeater. Another tool you might be familiar with is something called curl, or command line URL. You might want a CGI scanner like Nikto. And then if you actually have access to the source code, maybe you want to use some kind of a source code analysis tool, or maybe you just have a bunch of keywords that you'd want to search for in the code. That would be another way to go about it. So the basic approach, if you're going to test a web application for vulnerabilities, first mapping the attack surface of the application. So crawling through and inventorying all the requests and responses. So you saw Burp had that history, that history we saw. That was basically a log of all the requests and responses sent between the browser and the server. You're going to want to go through and click on all the links, fill in all the form fields, basically exercise the full functionality of the data. And then additionally, folks, maybe even you separate your crawl into an unauthenticated space as well as authenticated space. You do that completely separately. Additionally, maybe you have different user accounts, like a normal user and an admin user. So you crawl in the context of those different accounts. And then as you're crawling through the application, keep an eye on any sort of key requests or interesting functionality. So maybe if you saw file upload functionality, maybe you don't go testing it right then and there. You note it down to come back to it later. And then once you've built that map of all the different requests, essentially you just start working through it and doing your fuzz testing of the various get and post parameters. And again, unfortunately, we didn't really get to talk about authentication testing and authorization testing, but the point of separating your crawls into unauthenticated and authenticated crawls is if you wanted to test that authentication is being properly enforced across all application resources, you would basically take that log of all requests that are issued when the user is logged in and replay them without a valid session cookie, and then see if you can actually access that page. And you do something similar for testing whether you can access privileged functionality. So that, in a nutshell, is sort of how you're gonna go about testing a web application. So for the homework, you're gonna get the opportunity to actually hack a live web application. We'd like you to identify and document at least 5 vulnerabilities. We'll send out an email with the actual URL to the website and all the instructions you're going to need to get started. And we'd like you to basically, for each issue, identify, document what you'd classify the vulnerability as, provide a brief description and an example exploit, and then just some basic rules of engagement. If you find SQL injection, the use of drop command is absolutely forbidden. Not that you wouldn't even be able to do this anyway, but don't even try it. Keep all your attacks within the actual domain of the actual website, so don't go like linking to other places if there's any cross-site scripting vulnerabilities. And we'll be sending out an email, the next day or so. But pretty much it'll probably be up by Wednesday, and then you'll have from Wednesday to Monday to complete it.